But that in the previous lesson that we had, which was sometime in Monday, we looked into finding your surface area. So surface area basically means if you have a shape like this disinfectant bottle, you're just trying to find the area on the outside of it. Okay, that's all surface area is. And a lot of the shapes that you work with in surface area, you can actually break down into simpler shapes. Okay, let's look at, for example, this triangular prism that might look something like this. Okay, triangular prism looks something like this. Okay, that's a very beautiful prism. And then you can break it down and unfold it like this. So we looked at nets and how nets work. Remember, for the nets, the idea behind the net is you're just trying to open up the shape into simpler shapes so you can actually see what it is you're working with. Okay. For example here, cube can look like this. It's got 6 faces. A rectangular prism can look like that. So you've got, for example, these 2 sides are the same. Then you might have these 2 sides, and you might have like these 2 sides being the same. So there's 3 sides, and they have pairs. Okay, a triangular prism might look something like this. So you've got maybe all these sides being the same, and then you might have like the triangles being the same, and that's it. And then for a cylinder, which most people, I think may not have done before, you've got obviously your circles, and then you've got the rectangle here. Okay, but keeping in mind that with this rectangle, this length, as we discovered, is actually the same as the circumference of the circle. Okay, so just keep that in mind, that the length of the rectangle, same as the circumference of the circle, and to find the circumference, it's just pi times d for the circumference. So keep that in mind. I think it's in the notes. If you've forgotten how to do that, watch the videos so you can get it again. Okay, so you're finding the circumference to find the length of that rectangle there. Yeah, so you need to use that formula. And again, the basic principle behind nets is to just break it down into the simpler shapes so you can actually work out the area of each face. Let's look at this example here, this triangular prism. Okay, I've got all these sides. So I've got side 1, side 2, side 3, and you've got side 4 here, okay, which are both the same. All right, so side 1, you've got this rectangle, it's a 6 by 3. Side 2 is a 6 by 5. Side 3, that's 6 by 4. And then you've got the 2 triangles there, okay, which is a 4 by 3. Now, I remember I said to one of you guys that sheet we did, so this is going to be very, very helpful. This one here. Okay, so please put this in your bound reference because this is where all your basic formulas are for your surface or your areas. Okay, so you can use my examples there, put it in your notes. It's just good to have in case you've forgotten how you... Most people will forget how to find the area, for example, of the sector. Sometimes you'll forget the circle. Sometimes you might even forget the trapezium or the kite. Okay, so please make sure you have a copy of this in your notes. Yes?
How would you find the surface area of the sphere?
We're not going to be doing it, but it's 4/3 times pi r squared, I think. That's the formula for it. We don't really use the sphere. We won't be going through the sphere because it's not required in year 10. All right, let's go to, good question though. Let's go to what we're actually doing today. So our focus, we're on slide number 53, as I said, or 52, sorry. No, 53. And we're going to look into surface area again, but this time it's with composite solids. Okay, remember what that composite word means. Composite just means putting 2 things together, or a bunch of things put together. Okay, composite can look like a lot of different things. Solids, okay, will consist of more than one item. Okay, composite means a bunch of things put together. Okay, but again, it can be broken down into smaller parts. Okay, always broken down. So what we're going to focus on today, obviously, is to find or calculate surface area of your composite solids. Okay, surface area of the composite solids. So that's what we're trying to aim to understand today. And we're going to try and, as a success criteria, identify what is the 3D shape, or what is it that makes up the 3D shape, sorry, and identify the exposed areas of the 3D shape. Yep, we'll get into that in a second, and then calculate the surface areas. Okay, this keyword here, exposed, just means what is the actual area that you can see. Okay, what is the area that you can see that you can calculate? All right, so that's what we're going to look into. All right, so as a starter, let's go to slide number 55, which is what we should be up to. Let's close our laptops. Slide 55. All right, boys, close your laptops, please. Come on. That's right, you can finish it later. All right, let's get to this so we can actually start doing some work. All right, so as we've been learning, the idea behind today's lesson is to calculate the surface area of your composite solid. So a composite solid basically just means two shapes put together. Okay, if you look at this shape, for example, it's a composite solid that can be broken up into a cylinder and a cone. Okay, so you've got two shapes, the cylinder and the cone. But whenever you find the surface area of a composite solid, what you want to look at only is the exposed section. So remember, only the areas that you can actually see. If you put these two together, what area can't you see? Have a think about it. If you put these two shapes together, what area are you unable to see? Yeah, so the base of the cone, so underneath the cone, and there's also one more face that you can't see. The top of the cylinder, good. So you can't actually see these two parts, so underneath the cone and the top of the cylinder, which means that you don't add or you don't calculate those areas. Okay, you only want to look at the exposed areas, so the area that you can see. All right, so let's look at some examples here. What shapes make up the following composite solids? So let's look at this one. What shape can you break this down into? Two rectangles, yep. So you can cut it this way. Okay, so you'll have that rectangle there, and then you'll have a really long one here that goes like this. Okay, or what's the other way that you could cut it? Well, some of you might have gone this way as well. This also works where you go this way. So that means you'll have a rectangle that looks like that, there, and then a shorter one that goes like this. Okay, so the premise behind this, again, is you're going to break up your shapes into its basic parts and find its areas. Now, thinking about the way you cut it, when you do this, make sure that you don't include some of the areas that are covered or that are not exposed. Like, for example, with this shape here, remember that this area will not be included. Okay, because it's covered by this area over here if you put them together. Okay, so just watch out for the way that we do them. It'll make more sense if it's not making sense now as we go. This shape here, okay, you've got, again, two little shapes that you can break them up into. What are they, guys? What are the two shapes you can break this one into? Yes?
Triangular prism and a rectangle.
Good, so the triangular prism that will look like this. All right, and there. And thinking about the triangular prism, what area won't you include in the triangular prism? The bottom, good, so the base. So you don't include underneath here, just on the bottom, because it's not exposed. And then the other one, as Dylan mentioned, is the rectangular prism that looks like this. Okay, but what won't you include in the rectangular prism? The top, because it's covered. Okay, you don't include areas that are not exposed. So only the exposed sections. And then obviously this one, we'll just go through it quickly. It's a half cylinder if you break it up. So you've got this. As you can see, I do like to draw my shapes. So if you like drawing your shapes as well, guys, go for it. It does help you to sort of conceptualize what you have to look for. So for this shape, okay, I'm not including the base, so that's not included. And I'm not including the top, okay, because they're covered. Okay, you don't include anything that's not exposed. Only the exposed sections. Okay, we've done that. All right, so let's do some practice questions. There should be some here. Here is a design of a marquee. So let's go to page or slide number 57. And this is something that you're all probably going to be doing at some point. My partner, and this is going to be on YouTube now, for her bridal party wants to hire a marquee. and they have to measure the size of it, and that'll be the cost of it. Okay. So if at some point you want to do the same thing, maybe you can learn something from here. Now let's think about a marquee. So a marquee is basically like do you know what a pergola is? Kind of like a pergola. So it's like a roof.
It's like a tent.
It's like a tent. There you go. That's probably a better idea. It's like a tent. But what's different about this marquee is that if you're going to set a marquee up outside or a tent outside, are you going to have a bottom or a base? No, okay, you're not, because the floor is basically just the ground, okay? So just think about that when you do this. So let's find a surface area for this. I can see that this shape, okay, can be broken up into two parts. So you've got your triangular prism at the top, which is the roof, okay? And then you've obviously got the rectangular prism on the bottom. But let's just work with the triangular prism at the top and find the surface area for it. So according to this, the height of my triangle is 3, and these two lengths, this is an isosceles triangle because two sides are equal. Okay, they're 5, and that base length here, so the base of my triangle is 8. All right, so let's draw that, if you haven't already, the dimensions of this triangular prism, and then we're going to find the surface area for it. Remember, you're only trying to find the area of the exposed sections. You do not want to find the area of the sections that are covered, or that won't count. So if I think about how this shape will work, okay, if I want to make the net for it, you can go ahead and do that. But because, remember, you're only trying to find the areas that are exposed, this shape is going to have, obviously, your two triangles. I'm just going to draw it here. Let's do another color. You'll have your two triangles. And remember, for your triangle, okay, your dimensions are, this is going to be 8, and the height of the triangle is 5. Okay, that's the first one.
Is that 3?
Sorry, 3. What am I doing? Thank you. Thank you. Second part. Okay, you've got now the other sides of the actual tent itself. Okay, so you've got 2 of those rectangular sides. So we'll do that in blue. So dimensions of that. Okay, I haven't fully finished labeling this triangle. I forgot this side here. So this side here is 10, so that must also be 10. Okay, so let's just put that here as well. So this side is 10. That means on my rectangular part of the roof, this is 8 and this is 10. And I have 2 of those. Okay, because I've got this side here and also this side here on the other side. Okay, now why don't I add the third side, guys? Because you don't see it, it's not exposed, and you're not going to have a roof or a ceiling inside your tent. That's just silly. So you don't include the third side there. So now we can calculate the area of this and add them together. So let's go with the first one. This is a triangle. Remember the formula for a triangle? Base times height divided by 2. So that would be 8 times 3. Oops. 8 times 3 divided by 2. And you've got to multiply it by 2 because there's 2 of those triangles. Don't forget that. So that should be 24. So that's the 2 triangles. Yes?
For the rectangles, where do you get the 8 from?
The 8 is from the base of the actual shape here. So this, I was labeled it wrong, haven't I? It shouldn't be 8 because that's that. What should it be? This idea.
5.
Should be 5. Good. Thanks for catching that. My bad. 5. Thank you, Hutton. So for the rectangle, it's a 10 by 5. So we know that the triangle is rectangle is length times width. So it's going to be 10 by 5, which times it by 2 because there's 2 sides. So that will equal 100. Thank you. So the roof itself is 100. All right, we can start with that. The side parts of the roof itself is 100, but then putting them together, so the total area for this, when you add them all together, is 124. Okay, and we'll keep that in mind. So that's just the first part, 124. All right, so the next part now is the rest of that rectangle. Okay, on the bottom. Now remember, keeping in mind that when you do this, you're only adding the exposed section. So let's move on to the next part. I'm going to draw my rectangle here. You don't have to draw your shapes. I highly recommend, if you actually can do this without having to draw the shapes and just show the working out, that's fine. Okay, but you have to show the working out at least. You don't have to draw the shapes. I do like to draw them just so that you can see on my examples what is happening. So for the next part of my rectangular prism, this is 7, this is 8, and this is 10. Okay, that's really all I need to know for this. And keeping in mind that we're not actually calculating the area of the top here. Okay, why is that? Because it's not exposed. And there's also one more side that we're not calculating. Anyone know? The bottom. Okay, you're not calculating the bottom because it's not exposed. Okay, so you're only calculating this side, this side, this side, and that back side. Okay, that's really the only sides you're calculating here. Okay, so let's do that. So the first, if you look at my faces, I've got the front side here. It's a 7 by 8, and there's 2 of them. Okay, because there's a back side there, over here in the back, 7 by 8, and then you've got the other side, which is these sides here. Okay, we'll go blue for that one. So that one there, the longer rectangle, is a 10 by 7. 7 because this length and this length are the same. Okay, so that must be 7. Right, and there's also 2 of them. Right, so calculating that, nice and easy. 7 by 8 by 2. Okay, that's 56, so 112. And then for this one, 10 by 7 by 2. So 10 times 7 times 2 should equal 140. Alright, so when you add them together, that should equal 252 all up. Okay, that's 252. Now, adding all of that together to get the final surface area. Surface area I find for composite shapes in this topic is probably the trickiest one because there's a lot to consider on what you're adding. All right, so if you can do this, everything else will be easier. All right, adding them together, so 124 plus the 252 will equal 673. So the total surface area, or the TSA, total surface area, just don't get scared of that, is 376 meters squared. All right, now you'll come across a question like this in the SAC, I can guarantee it. That we're not quite done yet, okay? Because there's also one more thing to consider. If you read the rest of the question, it says, okay, that the marquee costs $25 per square meter. So we now need to calculate the cost of it. So if your total surface area is 376 and each meter is $25, so 376 times 25. Just put it in your calculator. That's a very big number. So 376 times by the $25 equals 9,400 as a total cost to calculate this. Okay. Cool. Any questions with that? I think there's going to be a few more examples that we can do as we go. Okay, but that's basically how we do the surface area. Again, you don't actually have to draw the shapes if you don't want to. If you can, in your mind, visualize what it is you're looking for, that's totally fine. You just need to show the working out. Okay, just make sure you show your working out. Where were we? So that's 9.4. Okay. Here's a challenge for you guys, and then we'll start working. I want you to find the surface area for this shape. So it's basically a cube, but then it's got a cylinder cut inside. Okay, so it's a cube, but there's a cylinder hole in the inside. Okay, I'm going to draw it for you guys. It's a cube. Looks like this. My amazing drawing. That's a horrible drawing. Let me fix that up. So it's a cube, like this, but then there's actually a hole on the inside. It looks like this. Okay, so it's a hole, looks like that, and it runs through the whole cube. Okay, through the whole cube there's a hole. So I want you to find the total surface area for this cube. See if you guys can do it. All right, you work with the person next to you. See if you can